The domain of a function is the stuff you're allowed to use as input. It's the allowable x values. And we can write these x values in set notation or in interval notation or just describe them informally. So that's probably what we'll see most often in this course. For example, if I have a function f of x equals x squared, I know I can put any value of x in there and I'm not going to have a problem. And so what I want to say is that the domain of this function is all numbers, in particular, all what we call real numbers. So that's all integers, irrationals, everything. So all real numbers. If you happen to know the notation, that looks like this, a little funny R. Usually the domain will be all real numbers with maybe a few excluded values. So for example, suppose I had the function f of x equals 1 over x. That's the machine that takes a value as input and outputs 1 over that value. So like f of 3 is 1 over 3. What values of x am I not allowed to put in this machine? What values of x would break the machine, would give you would give you error on your calculator? Well, I know I can't do 1 divided by 0, so I can't put 0 into this function. Everything else would be fine. There's no other problems with this function except the x equals 0 because I get 0 in the denominator. So I want to say that the domain of this function is all real numbers except x equals 0. And there's a few ways you could say that. I would be fine if you just said the domain is x not equal to 0. More formally, you could write x belonging to the real numbers such that x is not equal to 0. Here's another example, the square root of x. Are there any values of x that would break this machine? This is the square root machine. So I put in 4 into this machine and I get root 4, which is 2. If I tried to put negative numbers into this machine, the machine would break. I can put 0, but I can't put anything less than 0. So the domain is all positive numbers. So you could write that as x bigger than or equal to 0 in interval notation. If there is a value of x or values of x that are not included in the function's domain, we say the function is undefined at that value. So f of x equals 1 over x, I would say this is f is undefined when x equals 0. So that's just the language we use to talk about values that aren't in the domain. So this function g of x is undefined for negative numbers. There's no definition, there's no y values for those values of x. So if you're wondering, how do I come up with the domain? It's easiest, as I just did above, to think about what you're not allowed to use as input. So the domain is all the stuff you're allowed to use. Easiest to think about what you're not allowed to use, because usually there's only a few, if any. So when you're thinking about that, you want to keep these things in mind. 0 in the denominator, that's the most common thing. If you've got a denominator in your function, so if you have f of x equals x plus 2 over x minus 5, if you've got a denominator, then there's the possibility that that denominator is 0. So you have to think about, when is that denominator 0? In this case, you are not allowed to have 5, x equals 5, because then the bottom would be 5 minus 5, which is 0. So that's one place to look when you're trying to figure out domain. Negative under square root will also come up. So if you have square roots in your function, you're going to have some numbers excluded from the domain because you won't be able to put negatives under the root. There are also some specific functions like ln of x that have values excluded from their domains for other reasons, and we'll review these elsewhere. As you work through the practice worksheet on function, keep in mind that a function is a machine with input and output, that there's a relationship between the input independent variable and output dependent variable, and some functions have only a subset of numbers that you're allowed to use as input, and that set of numbers that you're allowed to use as input is called the function's domain.